Hi everyone, in Algebra 3, we are going to be going over your questions on Lesson 65. I will be doing all of those problems from Lesson 65, so if you need help with specific ones, make sure you're going through this video. Your stamp was already due for this lesson, so I will be completing the rest of it. So number 1, we have the cost of doing business varied linearly with the number of hours the store was open. If the store was open 40 hours a week, the cost was $1,200. But if the store was open only 20 hours a week, the cost was $800. What would it cost to keep the store open 30 hours a week? Well, our equation that they give us says the cost varied linearly to the number of hours opened. So for number 1, it's C equals MN plus B. C is our cost, N is the number of hours the store was open. So we're going to come up with two equations based off of these numbers. It says $1,200 for 40 hours. And then it says $800 for 20 hours. So 800. Now I have to solve for M and B. So what I'm going to do is I'm going to leave the top equation as is. The bottom equation, I'm going to actually multiply by -1. That would be -800, -20m, and -b. Now my b's are going to cancel, and I have 400 equals 20m. Now, when I divide 400 by 20, I get m is equal to 20, but I have to still solve for plus b. So I'm going to take that 20 and either plug it into the top or the middle equation or bottom equation. I'm going to plug it into the bottom. So 800 equals 20 times 20 plus b. Well, 20 times 20 would be 400. So when I bring it to the other side, I'm going to subtract 400. And I'm going to get b is equal to 400. So my equation, where cost varies linearly to the number of hours open, is going to be cost is equal to 20, or m, times the number of hours open plus 400. So when it says what would it cost to keep the store open for 30 hours a week, the cost would be the cost is what we're solving for, and the number of hours that we're solving for is 30. So all we need to do is do 20 times 30 and then add it to 400, and our cost would be equal to $1,000. Our cost is equal to $1,000, and that concludes the problem number 1. Now moving on to number 2. We have how many 3-digit counting numbers, all of whose digits are even, are less than 401. Well, this one's tricky because they're actually trying to throw you off here. So I have 3-digit counting number. If we're going to do less than 400, that means my hundreds will be less than 4, has to be even, all of them have to be even. So I'm only choosing from the numbers 0, 2, 4, 6, and 8. It doesn't say that repetition is not permitted, so all my variables that are less than 4 that could be used in the hundred spot, I only have 1. Now, these only have the conditions of even, so I can use any of those numbers, so those boxes would be filled with 5 and 5. So right now I think that my answer is 25, but we're missing one, and the one that we're missing is that isn't the number 400, isn't all these digits even? And isn't this 400 less than 401? It is. So I need to add one more to that, which would give me a result of 26 different numbers that would be all even, where all the digits are even that are less than 401. So that one was tricky because they threw in the 401. We have to be very specific. Now moving on to number 3. Number 3 says how many distinguishable permutations can be formed from the letters in the word Mississippi. Well, distinguishable permutations means that we have some numbers that are going to be doubled. So I'm going to do n factorial over a factorial, b factorial. I'm going to first start by counting how many letters I have. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I have a total of 11 letters. Now I'm going to go for my repetition. So how many I's do I have? 1, 2, 3, 4. How many S's do I have? I have 4. And then how many P's do I have? I think I have 2. And those are all your multiples in the problem. So what we're going to do is we make this 11 factorial over the number that are like factorial. So it'd be 4 factorial, 4 factorial, 2 factorial. Now, what we can do is we could simplify this, or we could do it all in our calculator. So I'm going to do it in my calculator. So I have 11 factorial. And what I'm going to do, so I'll just write that down. So 3, 9, 9, 1, 6, 8, 0, 0. Then I'm going to do 4 factorial times 4 factorial. Oops. So 4 factorial times 4 factorial times 2 equals 1,152. So when I divide this, I have 399,16800 divided by 1152 gives me a result of 34,650. And that would be your result for number 2. Now moving on, looking at number 4. So for number 4, we have the wheels on the car had a 30 centimeter radius and the car was traveling at 45 kilometers per hour. What was the angular velocity of the wheels in radians per minute? Well, for number 4, the equation for velocity is equal to angular velocity multiplied by the radius. If I'm solving for the angular velocity, I need to multiply it by the reciprocal of r, which would be 1 over r. So my angular velocity is going to be equal to linear velocity times the 1 over the radius. So knowing that information, I know that my velocity that I'm given is 45 kilometers per hour. I also know that my radius is equal to 30 centimeters. Now I need to convert this to radians per minute. So that means I have to get rid of the centimeters and kilometers and get this from hours to minutes. So there are 100 centimeters in 1 meter. There are 1,000 meters in 1 kilometer. And then my kilometers cancel. There is 1 hour and 60 minutes. Since I no longer have a unit of measurement, that's when I'm going to plug in my radians. So my answer is going to be 45 times 100 times 1,000 over 30 times 60, and that's going to be radians per minute. So I can plug that in because I no longer have a unit of measurement at the top, and then it's going to be over minutes. Moving on to number 5. Number 5 is one of our simpler problems. It says the latitude of Albany is 42.6 degrees north of the equator. What is the distance from Albany to the equator if the diameter of the earth is 7,920? So for number 10, the distance would be equal to x degrees over 360 times pi times diameter. And in this case, my x is going to be 42.6 degrees over 360 times pi times 7,920, which is the diameter of the Earth. So that would be 42.6 times pi times 7,920, all of that divided by 360, which would give me a result of 2,944.30 miles. And that would be your result for number 5. Now looking at number 6, it says Kathy traveled M miles in H hours, then traveled X miles in H plus 4 hours. At the same overall average rate, how long would it take her to travel 50 miles? So I'm going to solve for what her overall average rate is first. And for number 6, overall rate is equal to overall distance divided by overall time. So in this case, she traveled N miles, then X miles, that would be M plus X. And for her time, she traveled H hours and then H plus 4. So that would be H plus 4, giving me an overall rate of M plus X over 2H plus 4. Now we're gonna just use the equation distance equals rate times time. We're traveling 50 miles. My rate is this M plus X over 2H plus 4 times time. Now, if I want to solve for time, I would multiply by the reciprocal. So time would be equal to 50 times 2H plus 4 over M plus X. But notice that you can actually factor out a 2 out of the top in the parentheses. So if I multiply that 2 times 50, my time is actually going to be 100 times H plus 2 over M plus X. And I think that's how they leave it in the answer key. So they factored out of the 2 out of the 2H plus 4, then multiplied that by the 50. And that's how they ended up with that result. Now looking at number 7. Number 7 says Kyle traveled X miles at P miles per hour. Keith also traveled X miles, but at a faster rate of R miles per hour. How many more hours did it take Kyle to make the trip? Okay, so I have the distance of Kyle is X miles. The rate of Kyle is P, which means the time of Kyle is going to be X over P. Then I have the distance of Keith, which is also X, but the rate of Keith is going to be R, so that means the time of Keith will be X over R. It says how many more hours did it take Kyle to make the trip? Because Keith went faster, that means Kyle's time is longer, so longer. So if I want to find the difference between the two, I would take the longer one and subtract the shorter one. So that means I would have a result of Rx minus Px over PR. And I think for this one, they would factor out the X, but it's not really necessary. So if you didn't, that's fine. This is also a concept review problem. Moving on to number 8. So for number 8, it says Carrie bought K squared X plus M pencils for $D. How many pencils could she buy for $500? Well, I have this equation. It's cost per item for number 8. Cost per times the number of items equals the amount spent. So I'm going to just start with this top line. She bought K squared X plus M pencils for $D. So I'm solving for the cost per. Knowing that she bought this many pencils for $D. So that means the cost per pencil is actually going to be D divided by K squared X plus M. Now I'm going to use that information to plug back into this equation here, giving me cost per, which is D over K squared X plus M, We're solving for the number of pencils equals $500 because that's how much she's spending now. Now you're going to multiply both sides by the reciprocal, which would give you 500 times k squared x plus m over d. And that's pencils. And that would be your result for number 8. Now we're jumping all the way to number 16 because we've done the other problems when you initially learned this lesson. So for number 16, the first thing that we're going to do is solve for x, which means that we need to eliminate y. So for number 16, I'm going to start by multiplying the top equation by f and the bottom equation by negative d. So if I do that, I would get a fx plus dfy equals fg. Bottom equation, I'm multiplying by negative d, so that would be negative c dx, negative dfy equals negative dh. When I add those together, the y's are going to cancel out. I'm going to be left with a fx minus c dx equals fg minus dh. We're solving for x, meaning you're going to factor out the x on the left side, leaving you with af minus cd equals fg minus dh. So your answer for x is going to be fg minus dh over af minus cd. And that would be your result for number 16. Now for number 17, you are going to need to use your calculator because we're going to find the range, mean, median, mode, variance, standard deviation. So I'm going to start with, for number 17, is just finding the range, then the median, and the mode, and then doing the mean, standard deviation, and variance. So for the range, it's always the biggest number minus the smallest number. Now this isn't in order, so the biggest number is 9, the smallest number is 1. So the range would be 9 minus 1, which would be 8. I do want to relist this in order, so I'm going to do 1, 3, 5, 7, 9, 9. The median, the middle number, would be between 5 and 7. So what's between 5 and 7? You should know that's 6. The mode is the number that shows up the most, and in this case, that would be 9. So now what we're going to do is we're going to use this information to solve for the mean, standard deviation, and the variance. So I'm going to start by clearing my calculator, doing second 7, and that clears my calculator. And then I need to enter every single variable. So I'm going to enter all of my variables, and then in between each variable, hitting this button, which is right below the pi button. So that'd be 1, 3, 5, 7, 9, and 9. And it should say n is equal to 6 because I've entered 6 variables. Now I'm going to find the mean, I'm going to do second x squared. That means the mean is going to be 5.67. For the standard deviation, I'm going to do second divide. So second divide, which gives me 2.98. And then I'm going to do my variance, which means I just need to square the standard deviation. And that gives me 8.89. And those are my results for number 17. Now looking at number 18, this one has to do with with the same lesson, it says the data are normally distributed with a mean of 0 and a standard deviation of 1. Approximately what percentage of the data values lies between -1 and 1? Well, we have our three percentages, which are 68, 95, and 99. The first one is the mean plus or minus 1 standard deviation. The second is the mean plus or minus 2 times the standard deviation. And the last one is the mean plus or minus 3 times the standard deviation. Now the mean on this one is 0 and the standard deviation is 1. So I'm going to try the first one. So mean is 0 plus or minus 1 times 1. Well, 1 times 1 is 1. So 0 minus 1 would be -1. And 0 plus 1 would be 1. Well, approximately what percentage of the data lies between -1 and 1? -1 to 1. And that percentage was 68%. So what I did was I listed out those percentages, and then I plugged in the variables that they gave me, and that then told me what my percentage was going to be. So you have to plug them into all of them to see, well, which one of the ranges matched the range that we were given. Now moving on to number 19. So for number 19, I see that I have cosine 3 theta. I'm going to move that root 3 over 2 to the other side, which would make it cosine 3 theta is equal to negative root 3 over 2. Now using my chart of all students take calculus, I know that everything is positive in quadrant 1, so I'm going to say that's positive. I also know that cosine is positive in quadrant 4, so I'm going to put that positive. That means it's negative in quadrants 2 and 3. Now this is adjacent over hypotenuse, so my adjacent is negative root 3, my hypotenuse is 2. Now between both of those angles, I have 3 theta, that's a 30-degree angle. So in quadrant 2, I would have to subtract that 30-degree angle from 180, giving me 150. And then in quadrant 3, I'd have to add it to 180, which would be 210. Remember that you have to set each of those degrees equal to 3 theta because you can't divide off that 3 until after you solve for the degree. It also tells me that there's going to be 3 answers for each quadrant. So for my first answer, I'm going to have theta is equal to 50. Second answer, I'm going to have theta is equal to 70. Now what you're going to do is I have to find my other answers by setting 3 theta equal to 360. When I divide it by 3, I get 120. Now that's not one of your answers, but that's going to be the difference between your first answer and the next answer and then the following answer. So I'm going to add 120 to 50, which would give me 170. Add 120 to that, which would give me 290. So it'd be my first 3 answers. Second 3 answers, 70 plus 120 would be 190. And 190 plus 120 would be 310. And those would be my other answers. So you should come up with 6 answers, 3 answers for each of the quadrants for number 19. Now moving on to number 20. So for number 20, anytime you see a number outside your logarithm, it's actually going to become the exponent. So for this one, that 2 is going to become the exponent of the x. So I have ln x squared equals ln 6 minus x. Now, anytime you see an ln, that is actually a log with a base of e. So to get rid of the ln, I'm going to raise it to the power of e. That would cancel out my ln. So I would have x squared equals 6 minus x. Now to solve, I'm going to set this equal to 0. That would give me x squared plus x minus 6 equals 0. That actually does factor out evenly. It factors into x plus 3 times x minus 2 equals 0. And when I solve, I would get x is equal to -3 and then x is equal to 2. You do need to check your answers back in the original answer question. We can never take the logarithm of a negative number. So obviously if I plugged in -3 into there, that would be the log of a negative number. So your only answer is going to be x is equal to 2. So make sure you're checking your answer anytime you end up with 2 answers, because you can never take the logarithm of a negative number. Now looking at number 21, the same thing applies. The numbers outside the exponent, it is going to become, or if the number is outside of the log, it becomes the exponent. So for number 21, that's going to turn into ln of x cubed equals ln of 8 plus ln of 2 to the third. Now, because there's a plus sign between my two logarithms, I'm going to multiply those two variables together. 2 to the third is equal to 8. So 8 times 8 would be 64. Again, getting rid of the ln, you raise it to the power of e. Now we need the cubed root of 64. So 64, the cubed root of that would be 4. So x is equal to 4. Now looking at number 22. So for number 22, the rules still apply when they're in the exponent. So if you can see, there's a small 2 on the outside of the log, even though it's in the exponent, it's still going to go to the exponent of the 3. So that would be 7 to the log 7 of 3 squared. There's a minus sign between your logarithms. It's still going to mean you divide those variables. So that would be log 8 of 6 divided by 3. This last one, there's a 4 outside the logarithm. So that means that that gets raised to the power, even though there's already a power. So now I have 7 to the log 7 of 9 plus 8 to the log 8 of 2 minus log 9 to the 2, because 4 times 1/2 is 2. Now, my 7 and my log 7 are going to cancel. My 8 and my log 8 cancel, and my log 9 and 9 cancel. So what you are left with is 9 plus 2 minus 2, leaving you with as a result of 9. Now moving on to number 23 and number 24. That one, they both say to write these in terms of a sine function. So your equation is going to be y equals a plus or minus b sine c of theta minus d. So if we look at this problem here, we're looking at number 23 first. It says to write this in terms of a sine function. So what I'm going to do first is I'm going to solve for what a is going to be equal to. Now a is going to be equal to the midline, so where the x and the y axis are crossing. And the way you evaluate it is you take the top number and the bottom number and you find the midpoint between them. So for a, I'm going to do 6 plus -4 divided by 2. Now 6 plus -4 is actually 2, divided by 2 is 1. Now b is the distance between this 6 and this middle line. So b is actually the difference between the top, which is 6, and the middle line, which is 1. Now c is going to be, this is in radians, so it's 2 pi divided by the length of the period. Now I have to calculate the period length here. So the way I'm going to do that is, you see that on this one, that the period starting at -pi/4, it's going to circle down, circle up, and then That's actually a terrible one to choose. I would choose to go peak to peak. So it's starting at 3 pi over 4 and then ending at 5 pi over 4. So notice how it's peaking here, peaks again at 5 pi over 4. You take the absolute value of this radian measure and add it to this radian measure. So I'll show you how that works. That was 3 pi over 4 plus 5 pi over 4. Now 3 pi plus 5 pi would be 8 pi, and then 8 pi divided by 4 would be 2 pi. So 2 pi divided by 2 pi would just be 1. Now we're looking for the phase shift. Well, I want to see where is it's peaking. It's currently peaking at negative 3 pi over 4 and then again at 5 pi over 4. So either you can shift this back 5 pi over 4 or you can shift this forward 3 pi over 4. Because we want it to peak here at the middle. So either you shift this over positive 3 pi over 4 or shift it back 3 pi over 4. So your result is going to be as follows. Y is equal to A, which is 1, plus B, which is 5, sine C, which is 1, and I'm going to choose to shift this forward 3 pi over 4. And that would be your result. So for number 24, it's similar. We're going to start the same way. A is going to be the top plus the bottom divided by 2. So the top, we notice, is 16. The bottom is negative 4. So A would be 16 plus negative 4 divided by 2. So 16 minus 4 is 12 divided by 2 is 6. B is the difference between 16 and that number that we just got. So difference means subtraction, so it would be 16 minus 6, which would be 10. C is our coefficient. In this case, again, it's in radians, so it's 2 pi divided by the length of the period. Now let's calculate this period as starting at 0, circles up, circles down, ends at 7 pi. So notice how circles up, circles down, ends at 7 pi. So the length of the period is 7 pi. Now the pi's are going to cancel, so it would be 2 over 7. This is already a positive sine function because when x and y are crossing, it's sloping up. So it's already a positive sine function on this one. So we don't have to do a phase shift, so there's no d in that equation. Meaning that our result is just going to be y is equal to 6 plus 10 sine c, which is 2 over 7, and theta, because there's no phase shift. So now if we look back at the original equation that we were starting with, we had these two equations right here, y equals a plus b sine c theta minus d. In the first one, we did not have a c, but in the second one, we didn't have a d, so there's no d. So no c and then no d. So this one would mean there was a phase shift. This one would mean there's no phase shift because it was already a positive sine function. Okay, now moving on to number 25, we're trying to find the area of a triangle in square meters. Now this one's tricky because they give it to us in centimeters actually. So we have 10 centimeters as our base, and then we have 12 centimeters as our slant. And this would be 130 degrees. So I'm going to start by creating a right triangle on the outside. This angle would be 50 degrees. I'm trying to find the height. The hypotenuse would be the 12, so you're going to use sine. Sine of 50 is equal to opposite, which is height, over hypotenuse, which is 12, which means that your height is going to be equal to 12 times sine of 50 degrees. So in your calculator, it's going to be 12 times 50 sine equals, I have a height of 9.19. I'm going to just leave this in my calculator because when you find the area of a triangle, it's 1/2 base times height. Oops, base would be 10, sorry. The height would be 9.19. This 2 goes into the 10 5 times. So I would just really multiply my height times 5, and that would be my area. But remember that this is in centimeters squared. So this would be 45.96 centimeters squared, but I need this to be in square meters. So I need to convert this, and there's 1 meter in 100 centimeters, but I have to square it. So I'm not only going to divide this by 100, I'm dividing this by 100 squared. And that would give me a result of 0.0046 meters squared. So don't forget that you actually needed to convert this from centimeters to meters in the end. And you could have done that at the beginning, but that does make it a little trickier only because the numbers would have been so small. Now looking at number 26. Number 26, we're doing cosine of arctangent. So arctangent, everything's positive in quadrant 1, so I would draw my triangle in quadrant 1. Tangent is the ratio of opposite over adjacent, so opposite would be 6, adjacent would be 7. Now I'm going to solve for the hypotenuse using Pythagorean theorem. So h squared equals 6 squared plus 7 squared. So I have 36 plus 49 would be 85. I don't think you can take the square root of that. Yeah, so that would be just the square root of 85. But then what we're doing is we're actually taking the cosine of this triangle, and cosine is adjacent over hypotenuse. And that would be 7 over root 85. But you can't leave that root 85 in the denominator. So you should remember that you have to multiply top and bottom by the square root of 85, meaning that your result is 7 square root of 85 over 85. And that would be your result for number 26. Now for number 27, we have all of these that are all going to be the first line in each of our quadrants. So for this one, for 27, for pi over 2, that means I have only 2 lines between 0 and 180. Starting at 0, that means it's this line, which is that 90-degree line. And that would be 0, 1. Sine is equal to the y coordinate. Then for pi over 6, well, I know that's going to be in quadrant 1 because it's a positive 1. And I know that when it's over 6, it's a 30-degree angle. So that'd be root 3, 1, and 2. Cosine is adjacent over hypotenuse. The last one is negative pi over 4. And that means because it's negative, it would be in quadrant 4. Negative 1 goes down. And this would be a 45-degree angle. So this would be 1, negative 1, root 2. And tangent is opposite over adjacent. So now we have to just evaluate. So the y coordinate at 90 degrees is 1. So that would be 1 cubed. The adjacent over the hypotenuse in quadrant in this triangle here would be root 3 over 2, but you do need to square that. And then the tangent of this last triangle, opposite over adjacent, would be negative 1, but you do have to take that to the 4th power, which would be equal to positive 1. So 1 to the 3rd is 1, square root of 3 over 2 squared would be 3 over 4, and then plus 1. So that would really be 2 minus 3/4. 2 minus 3/4. Common denominator would be 8, minus 3 would be 5 over 4. And that would be your result for number 27. Now your last 3 problems, number 28, is to convert 600 kilometers per hour to miles per hour. So it's just converting from miles to, or kilometers to miles. So 600 kilometers per hour. So I'm going to start with going from kilometers to meters. So 1,000 meters, 1 kilometer, to centimeters, 100 centimeters, 1 meter, centimeters to inches, so 2.54 centimeters, 1 inch, inches to feet, 1 foot, 12 inches, and then 1 mile, 5,280 feet. So feet cancel, inches cancel, centimeters cancel, meters cancel, kilometers cancel, and you can rewrite your answer as 600 times 100 times 1,000 divided by 2.54 times 12 times 5,280, and that would be miles per hour. Lastly, or not lastly, number 29, the first thing that we have to do is for this problem for number 29 is our result is actually something that we want to look like a factored equation, which would look like this: x minus root times x minus root. That means that I would actually need to go through and actually solve for what the roots of this equation are. And to do that, you would need to do quadratic formula. So I'm going to start by solving for my roots. X is going to be equal to negative b plus or minus the square root, b squared minus 4 times a times c all over 2 times a. So I have negative 3 plus or minus the square root of 9 minus 28 over 2. And that would be negative 3 over 2 plus or minus the square root of 19i over 2. Now those are your roots, but then when you plug them in, you need to make sure that you change the signs. So this negative sign is going to turn into a positive. This positive sign is going to change into a negative. Then this negative again will change to a positive. And this negative will change to a positive. And that would be your factored equation. So solving for the roots would just mean solving for the quadratic formula. We're on our last problem, number 30. Number 30, it says that f of x is equal to x squared and g of x is equal to x plus 10 squared minus 2. Which of the following statements is true? Well, I know that this minus 2 on the outside means that it's going to be shifting down 2 spaces. So 2 units down, 2 units down. I'm only choosing from B and C. Now remember that they're replacing the x with x plus 10, which means that in order to get back to its original, it would need to move plus 10. So back to the origin, which means it's actually moving in the opposite direction. So this plus 10 is telling me that it's shifting to the left 10 spaces. So it's the opposite for the x, it's the exact way that's moving for y. So x plus 10 means it's moving to the left 10 spaces. And if you look at this, it says f translated 10 units to the right. It's not going to be b, meaning that f translates 10 units to the left and 2 units down. That's your answer. It's D. And that concludes all of your questions from lesson 65. Hope you guys all had a great day, and I hope you were able to follow this tutorial. Bye.